Now we look at example 5. Okay, so the question is a random sample of 1 to 0. Okay, so we have our n is equal to 1 to 0. Okay, so we have an average lifespan. Okay, so this average lifespan is from the sample. Okay, that means we have the x bar 71.8. Okay, so we also have the population of standard deviation. So that means this standard deviation of population is none. Okay, so our standard deviation of the population is 8.9. Okay, so the question asks, does this seem to indicate that the mean lifespan today is greater than 70? Yes. Okay, that means this one is our H1, mu greater than 70. Okay, that means we have only one mean. Okay, we have the single mean. And also we have the alpha. Our significant level is 0.01. Okay, we have a single mean. And we have the H1. Okay, the mean is greater than 70. That means this is a right tail. Okay, right tail test. Okay, it's a one tail test. Okay, that means our alpha is 0.01. We don't need to divide by 2. Okay, because this is right tail test, one tail test. Okay, now we already have our number of sample. Okay, our sample mean, our population of standard deviations, and also we also have the significant level. Okay, so we are looking for H1 in which our mean is greater than 70. Okay, so our H naught, okay, will always be equal to 70. Okay, for the H naught, we use the equal sign. Okay, and for H1 is the claim. Okay, from the question. Okay, now we know that our mean is greater than 70 is one tail test. Okay, that means it's a right tail test. So our alpha is 0.01. Okay, so now, so we are going to use the Z test. Why? Okay, because we already know the alpha is none. Okay, and our n is 1 to 0, in which greater than 30. So it's from the case A. Okay, we use the Z test. So when we want to use the Z test, that means we must refer to the Z table. Okay, so if we have the Z table, okay, we have 0.01, so we must look. Okay, when we have this Z table, this one is the critical region. So this is the value that we are looking. So we must get the critical region. So by looking from the Z table, we get our critical value is 2.325. Okay, so 2.325 is our critical value. So we draw an interval line. So we know that the critical value is the value that separates the rejection region and also non-rejection region. So when it is a right tail, that means we reject the region which is greater than critical value. So we reject here. Okay, that means this is do not reject H naught. Okay, so this is a rejection region, this is non-rejection region, and we know that when we reject the H naught for the rejection region and do not reject the H naught for the non-rejection region. So we mentioned that reject H naught if the test value. What is the test value? Test value is Z test. How to get the Z test? From the formula. Okay, so fall in the region. Okay, ZC greater. So we reject, okay, the H naught if the Z test for the region here. Okay, so now we calculate the Z test. Okay, we know that this is the formula of Z test. X bar minus mu over this sigma over the square root of n. So we have this value. We just substitute. Okay, this value in which we get from here. Okay, we substitute, then we get our Z test is 2.22. Okay, 2.22 is around here. Okay, it's around here. So we do not reject the H naught. Okay, Z test is equal to 2.22, which is less than ZC, greater than 2.35. So with the decision is do not reject the H naught. So when we do not reject the H naught, there is not enough evidence to support the claim in H1. Okay, so this is how we solve example 5. Okay, now we look at example 6. Okay, so we have the question. Okay, so that's the claim that the average age of Liget is different than. So we want to test the claim that is different than 33 years. So that means our H1 is equal to our mean is different. That means it's not equal to 33. So when we talk about the different, it can be greater or less than. That means it's not same. So he select a sample of 14. So our n is equal to 14. Okay, so that means it's less than 30. Okay, and find the mean of the samples. Okay, the mean of the sample is 32.1 with a sample standard deviation. Okay, so this is the standard deviations of the samples. Okay, not a standard deviation of the population. That means our standard deviation of the population is unknown. Okay, because we already given the standard deviation of the sample. Okay, so is there any evidence to support the claim by using the alpha? Okay, our significant level is 0.05. Okay, so this is the information, okay, that we get, okay, from the question, okay, in which our H1, okay, mean is not equal to 33. Okay, so this is our claim. Okay, now, so this is, okay, when we have not equal, okay, that means this is a two-tail test. Okay, two-tail test, that means it can be a right tail test or the left tail test. Okay, so when it is a two-tail test, that means our alpha must be divided by 2. Okay, so from the question we get our alpha is 0.05. So we must divide our alpha, okay, into 2 by 2 because this is a two-tail test. Then we get 0.025. Okay, now, so we know that from the question the alpha is unknown. Okay, sorry, the population. Okay, the population is unknown. Okay, and our n is equal to 14, in which less than 30. So we must use the case B. Okay, case B in the population of the standard deviation is unknown. Okay, then we must use the t-test. Okay, so when we want to use the t-test, okay, we know that our t-test, we must find the alpha. Okay, we already calculate alpha is 0.05, but because it's two-tail test, we must divide by 2, so our alpha is 0.025. Okay, and we must get our degree of freedom, our V. So our degree of freedom is V equal to n minus 1. So our n is equal to 14, so minus 1 then we get is equal to 13. Okay, so we are looking for, sorry, T. Okay, T test, okay, is 0.025 and our V is 13. Okay, so this is 3 distribution from the table 7. So 0.025 is here. Okay, so our degree of freedom is 13. So 13 is here. So 0.005 and 13. So our T critical value for T test is 2.16. Okay, so it's equal to 2.16. So our critical value, okay, for T test is 2.16. Okay, so this one we have right tails and also left tails. Okay, that means we have positive 2.16 and negative 2.16. So for right tails, okay, greater, and for the left tail test is less than negative 2.16. Okay, so this is the rejection region, or we reject H naught. Okay, so that's mean we do not reject H naught when it's come into the region, when it's fall into this region. So we mentioned that reject H naught if the T test falls in the region TC less than negative 2.16 or TC greater than 2.16. Okay, so we substitute all the information given from the formula in the t-test formula. Then we get our t-test is negative 1.6837. So negative 1.6837, so it falls around here. Okay, so in step 4, the test value if negative, so we do not reject the H naught. So when we do not reject the H naught, so there is not enough evidence to support our claim in H